Okay, we will discuss electric field intensity E due to infinite line charge using Gauss law. So here, infinite line charge we will consider on z axis. So this is x, y and z axis. So here this is we'll consider it as Gaussian surface which is closed and it is having a radius r. So we will consider this as some cylinder with radius r. Okay, so the height of the cylinder is L and the radius R. Okay, so here the point in the cylindrical coordinate system are R, phi, Z. So the differential elements corresponding to R is dr, phi is r d phi, Z is dz. So basically what we know with respect to Gauss law we will write first. So electric flux, total electric flux is equals to the surface integral of d dot ds, which is nothing but charge q enclosed. So here we know that this is a line charge they have given. We know that this rho L is line charge density. This can be written as q divided by L. Rho L is equal to q divided by L. So here q is nothing but what? Rho L into L. Okay, so q means charge and L means meter, so it is coulomb per meter, the rho L. Okay, so with the help of this we will proceed by taking this rho L into L as LHS and this one the closed surface integral of d dot ds. So now we should think about this RHS. What is D? D vector is nothing but the electric flux density. So here the considered is the radius R. So here D vector can be written as the scalar dr and the unit vector is in which direction? R direction. So it is AR. Similarly, we should write what is ds vector along the R. The ds vector means differential surface vector which is normal to R direction. So when you are writing the differential surface normal to R direction, so here you should not write the component which is corresponding to R. So you should write the components which is corresponding to phi and Z. So the phi differential element is R d phi. So write R d phi. With respect to Z, write the component as dz. So when you write these two, so the normal direction is R, so you should write it as AR. Okay, so this is DSR. Next, you just substitute here. This is R component and this is also R component. So here we will write it as rho L into L is equals to, so 2 times integrations we should take. So dr is nothing but dr AR and DSR is nothing but R d phi dz AR. Okay, so here the two integrations are there. These two integrations we should take the limits. Okay, one limit is with respect to z axis. So here dz with respect to z axis is the length 0 to L. Other is with respect to phi 0 to 2 pi. Okay, so now here you can just look at AR. So it is dot with AR is there. So we know that AR dot AR is 1. So we can write that, and meanwhile you can take this constant dr and r out. So take r and dr out. So write with respect to phi 0 to 2 pi. So here you can write d phi, and one more time write the integration 0 to L. So here it is with respect to dz. So write it. So AR dot AR is going to 1. So now solve this R dr. What is the integration of d phi is phi. The limits are 0 to 2 pi. And the integration of dz is z and it is 0 to L. Now how it is going to be is, so I will write here. So it is rho L is equals to, so I will take this here. So it is going to be r dr. So 2 pi minus 0 can be written as 2 pi, and this L minus 0 can be written as L. Okay, so here it is L and L will get cancelled. So you will end up with, so I will write with respect to dr. So dr can be written as rho L divided by 2 pi r. So if I write what is d vector, so it is going to be dr ar. So you can write what is dr. Dr is nothing but rho L divided by 2 pi r into r. So it is electric flux density. What it is? Electric flux density. What is the unit of electric flux density? Is coulomb per meter square. But what is the derivation is? E, electric field intensity due to infinite line charge. So this is electric flux density due to infinite line charge. So we should find what is E. We know the relationship between D and E, epsilon into E. So if you want E, you can write D divided by epsilon. So here D is rho L divided by epsilon means it is 2 pi epsilon R, and AR, the unit is volt per meter. So this is E. Okay, so this is the equation. Rho L stand for the line charge density. Here in the equation, R stands for the radius of the cylinder, and this AR stands for the direction. Okay, so this is how we can do the derivation. Initially it looked like how we should do this, E due to infinite line charge due to Guass law. So very important thing is we have used this Guass law. Psi is equals to d dot ds and q enclosed rho L L, and with the help of this analogy we have mode. Just to remember here, we can also write rho s as q divided by s. Okay, so it is q by s means it is coulomb per surface area, so it is meter square. So rho v can be written as q by volume, so it is cubic meter. Okay, so coulomb meters, cubic meter. So here this is how we should solve E due to infinite line charge using Gauss law. So like this, for the very brief explanations regarding the electromagnetic waves, do subscribe my channel and click on the bell icon for the latest notifications. So this type of things will be used for the ECE students as well as electrical students of the currently 5th semester or the 4th semester. Okay, so thank you.